so for this example, we have new set of notes, so let's get ready to write those down. So our 3 dot points. First one, if you see a minus C inside the sign, as you can see, this is a horizontal translation. Translation means movement, so you're just moving him through C units. Y equals plus D when it's on the outside. Maybe I'll write that little note for you. It's a vertical translation of y equals sine x through d units. Now, if it's minus c plus d, if you do horizontal and vertical translation, it's just called a translation, and with the vector c and d, so you have to apply both of them. So write those down and we'll give this a go. So example 3, we want to draw sine x, so our state, our regular one. So we'll give that a go. I might draw it a little bit bigger than usual, so maybe I'll go pi over 2. I'll change the scale a little bit. Pi, 3 pi over 2. So maybe a little bit bigger so it's easier to see. 1, 2, 3, 4, and then 2 pi. Okay, and then I'm going to do 1 and minus 1, so let's give it a go. So I'm going to draw sine x, so it just goes through that point, it meets at the maximums and the minimums, so I just go up, down, up, something like that, and label it. And then I need to figure out what this one is. So is that going to be dot point 1 or dot point 2? Well, y equals sine x take 1 is in the inside, so let's just write those notes. So inside was a horizontal translation. So it's a minus 1, so it moves 1 unit. So do you see how it says minus C, but it has moves C units? So although it was minus 1, it ends up being the opposite. So it's kind of opposite, if you want to write that note. Opposite sign. So it becomes plus 1 to the right. So that's what I'm going to draw. Now it gets a little bit tricky. I might just quickly look at the answer. It gets a bit tricky because we don't know what 1 is. So what they've done is they just wrote 1. Okay, because we don't know, I don't exactly remember what pi over 2 is, in decimals. So, because I don't actually know, I'm just going to draw it and then write it. Apparently that's just good enough. So we just move this point a little bit to the right, the same amount, right, same amount, right. Do you see the point? So hopefully you can kind of just trace it a little bit to the right. You understand the point? So it should look something like this, and then maybe you could write plus 1, wherever, kind of, plus 1. So you can kind of see that. That's good enough. Alright, let's try B. Oops, let me just write that equation. Alright, B it is. So y equals sine x. Give that a draw again. So pi over 2, pi, 3 pi over 2, and then 2 pi. And then 1 plus 1. So like this. And then I'm going to figure out what my take 1 does. Do you see how it's on the outside? So let's write my notes. Outside. It's going to be a vertical translation. D units, so -1 down. Okay, so I just have to go, this one's easier because, I have to move this point 1 down, this point 1 down, so it'll be at 0. This point 1 down, so it'll be at -2. This point will be at -1. So that goes 1 or down. Okay, so let's label those points. So hopefully I can make it look similar. So that's what you follow. So you go like this. And then you just go -1, -1, and you write your equation. And let me just double check. And that looks right to me. Cool. All done. So now you should be able to do 7b.2, your vertical and horizontal dilation. Give it a go and check your solutions.